Hello, this is Chris Evans, and this is my reassessment for the rotational dynamics assessment that we did in class last Monday, I believe. Okay, so the problems in the email and everything, it's just about that thing that spins around or whatever in space, the centrifuge or something, or Dean's ultracentrifuge. So anyway, so basically, what we do, the variables that we do have, we have the final velocity, which is 0. We have the initial velocity, which is 5.1 times 10 to the 5th. And then the acceleration, since it's slowing down, is negative 0.40 radians per second squared. Okay, so to find the time that it takes until we can use the formula, the final velocity equals the initial velocity plus the acceleration times the time, and basically resolve that and get time equals the final velocity over minus the initial velocity divided by acceleration, which is it's 0 minus 5.1 times 10 to the 5th, and then divided by 0.40, and to get the final answer is 1.3 times 10 to the 6th seconds. Okay, so that's the time, and then they wanted us to find the the amount of revolutions that it took during that time period. So then we can use this formula, the final theta equals initial theta, which is the amount of revolutions, or the amount of radians, plus the initial velocity times time plus 1/2 the acceleration times t squared. And so, and then final on the initial radians just equal theta, this is 1. So anyway, for the initial, we plug in the initial velocity, which is 5.1 times 10 to the 5th, times the time, which we found in the first problem, which is 1.3 times 10 to the 6th seconds. And then just plug in other numbers, plug the acceleration, which we know is negative 0.40, since it's got a negative acceleration. And then and again, we just use the same time that we found, which is 1.3 times 10 to the 6th squared. And basically, when you solve all that, you get 3.3 times 10 to the 11th radians. And we want to see how many that is in revolutions, how many revolutions that is. So we divide that 3.3 times 10 to the 11th divided by 2 times pi. And the amount of revolutions is 5.3 times 10 to the 10th revolutions. And that's that. I hope you enjoyed this. Have a great day.